All right, so chapter 6, section 1, we're going to find angle measures and polygons. So first we're going to start with the parts of a polygon. Each segment that forms a polygon is a side of the polygon. The common endpoints of two sides is the vertex of the polygon, and a segment that connects any two non-consecutive vertices is a diagonal. So first we have the vertex of the polygon, which is all of these points here. Next we have a diagonal, which connects two non-consecutive vertices. So like A and E are consecutive vertices, so it would connect A and B since those are not consecutive. It would connect E and C since those are not consecutive. We have B and D as a diagonal here also, and D and A. So those are all the possible diagonals that we have.
And the vertex is at every point?
Every like sharp point on the edge. Okay, so you can name a polygon by the number of its sides. The table shows the names of some common polygons. So we obviously know that if a shape has 3 sides, it's a triangle. That one we've been doing this whole time. With 4 sides, it's a quadrilateral. So think quad means 4. So 4 sides is a quadrilateral. A pentagon is 5, hexagon 6. And you can go down the list, but an important one is if it has n number of sides, so n can be any number, it's going to be a n-gon.
So 13-gon?
A 13-gon. So if it had 13 sides, it would be a 13-gon. If it had 20 sides, it would be a 20-gon. So to find the sum of the interior angle measures of a convex polygon, we draw all possible diagonals from one vertex of the polygon. This creates a set of triangles, and the sum of the angle measures all of the angles, all of the triangle. The sum of the angle measures of all of the triangles equals the sum of the angle measures of the polygon. So here we have a triangle. How many degrees is in a triangle? All 3 angles add up to what? 180. So in a quadrilateral, if we draw a diagonal, now we have 2 triangles. So we have one triangle with 180 and another triangle with 180. So how many degrees do you think that 4 angles of the quadrilateral are going to add up to? 360. In the pentagon, we have 3 triangles with 180. So what do you think all the angles are going to add up to in a pentagon? 540. So we just added 180 plus 180 plus 180. And then a hexagon, we have 4 triangles that are going to be 180 degrees. So what do you think all the angles in a hexagon are going to add up to? What is it? 720? Yes. So instead of drawing out each shape, each polygon, and drawing the number of triangles, there's actually a formula for this. So the formula is in this last line. So we do n minus 2 times 180, and that gives us the sum of the interior angles. So if we had a triangle, what would be our number of sides in a triangle? 3. So 3 minus 2 times 180 would give us what? 180. So this right here is the formula to find the sum of the interior angles. So these are all of the interior angles added up together. Okay, so for this theorem and the corollary, it says theorem 8.1, but you can just ignore the 8.1. It's not theorem 8.1, but the number of the theorem doesn't matter. What's important is that we have the polygon interior angles theorem. So the sum of the angle measures of the interior angles of a convex n-gon is n minus 2 times 180. That's what we did on the last slide. N minus 2 times 180. And next we have the corollary to the theorem of the interior angles of a quadrilateral. So this is just like, it goes along with the theorem above, but it's kind of just like a side note. So this says the sum of the measures of the interior angles of a quadrilateral is 360. So a quadrilateral, meaning that it has how many sides? 4. So if we did 4 minus 2 times 180, we get 360. So this corollary just says that the sum of the angles in a quadrilateral is 360. Next we have the polygon exterior angles theorem. So the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360. So at each vertex we're going to have an exterior angle. Exterior meaning what? On the outside. So we have angles on the outside, and all of these angles, no matter what polygon it is, it's going to be 360. So here we have a polygon with 5 sides. So what type of polygon is it? A pentagon. But if we had a triangle and we had one exterior angle at each vertex, all of these angles would add up to what? 360. So no matter how many sides it has, all the exterior angles are always going to add up to 360. So this is for exterior angles. So the measure of each interior angles in a regular polygon is going to be n minus 2 times 180 divided by n. So a regular polygon, meaning that all of the angles are going to be equal to each other. So if we had a square or rectangle, all the angles have to be equal to each other. So what did we say? How many sides does a quadrilateral have? 4. So if we do 4 minus 2 times 180, what do we get? 360. So 360 divided by n. So what's our number of sides? 4. So what's 360 divided by 4? 90. So in a square, or a quadrilateral here, all of these angles are going to be 90 degrees. Each angle will be 90 degrees. So a regular polygon means that all angles are equal. They're all the same. And this is the formula we use to find each angle. So now we're going to do some examples. Find the sum, so it's asking us for all the angles added together, of the interior and exterior angles of a heptagon. So how many sides does a heptagon have? 7. So what's the formula we're going to use? 7 minus 2 times 180. So 7 minus 2 is 5. So 5 times 180. 900. So the sum of the interior angles is going to be 900 degrees. So this is all of the angles in a heptagon added together. Now what will the sum of the exterior angles be in a heptagon? $360. It's the same always. So the sum of the exterior angles is 360. Whether it's a triangle, a quadrilateral, a pentagon, a heptagon, an n-gon, the exterior angles, the sum will always be 360. Okay, so let's do B. Now we have a 17-gon. So how many sides is it going to have?
17.
So what's our formula for the interior, the sum of the interior angles? 17 minus 2 times 180. What do we get? 15 times 180. What's 15 times 180? 2,700 degrees. So the sum of the interior angles is going to be 2,700 degrees in a 17-gon. What is the sum of the exterior angles going to be? 360.
So it's always 360, like it doesn't matter.
For the sum of the exterior angles, yes, always 360. Okay, last slide. Find the measure of each, so now it's asking for each interior angle and each exterior angle of the given polygon. So we have a regular quadrilateral. So how many sides does a quadrilateral have? 4. So what's our formula going to be?
Minus 2.
4 minus 2 times 180. So this gives us the sum, but we're finding each interior angle. So what do we need to do to this formula to find each angle? Divide by 4. So on top we get 360. On the bottom we get 4. So it's 360 divided by 4. What is it? 90. And how do we find each exterior angle? So the sum of the exterior angles is 360. But what do we need to do to find each one? Divide by 4. So 360 divided by 4? 90. So now let's do it for a regular octagon. How many sides does an octagon have?
8.
So what's our equation going to be to find each interior angle of an octagon? 8 minus 2 times 180 divided by what? 8. So what do we get? What is it?
135.
135?
Yeah, that's after dividing
Is that what you got? Okay. So 135 is going to be each angle. How do we find the exterior angles? 360 divided by 8. So what do we get?
45.
So each exterior angle of a regular octagon is going to be 45 degrees. We have a regular 15 gon. So how are we going to find each interior angle of a 15 gon? 15 minus 2 times 180 divided by 15. So what do we get?
156.
How much is it?
156.
156 degrees. So how do we find each exterior angle?
Divide by
360 divided by 15. What do we get? What is it? 24 degrees. And lastly for D, how do we find each interior angle of a regular 20 gon? 20 minus 2 times 180 divided by 20. What do we get? 162 degrees. And now how do we find each exterior angle? 360 divided by 20. 18 degrees. Okay, so we can only do this if they are regular polygons. Regular meaning what? All the angles are going to be the same and all the sides are the same. So any questions on 6.1? Yes.
What is concave or convex?
Okay, so number 2 says, tell whether each outlined shape is a polygon. If it is a polygon, name it by its number of sides. So a polygon needs to have straight lines, and they can't overlap. So for number 2, is this a polygon? Yes. And how many sides does it have?
5.
Well, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how do we name it by its number of sides if it has 10 sides? Decagon. For number 3, do you think 3 is a polygon? No, because it doesn't have straight lines. What about number 4?
Yes.
Yes. And how many sides does it have?
4.
So what type of polygon is it? A quadrilateral. I think I spelled it wrong, but it's fine. For number 5, is it a polygon? Is this a straight line here? No, so it's not a polygon. For 6, tell whether each polygon is regular, irregular, and tell whether it's concave or convex. So, for it to be regular, we need all the angles to be the same and all the sides to be the same. So for number 6, are all of our angles and all our sides the same? Yes. And before we get to concave or convex, let's look at number 7. Is 7 a regular or irregular polygon? Irregular, because we have this side that has 1 tick mark and this side that has 2, so those two sides are not the same measure, so it is irregular. So a concave polygon is if we connect 2 of the vertexes and part of the polygon goes inside. Okay, so it concaves into the shape. So like for number 2, we connect 2 of the vertices here and it goes inside, so this would be concaving. But for 6, when we connect any of the vertices, it doesn't go inside, so does it concave? No, so it would be convex. So now let's look at number 8. Is this a regular or irregular polygon? Irregular, because we have this angle that has 1 arc mark and this one has 2. So they're not the same measure, so it's irregular. Do you think it concaves or is it convex? Convex. Okay, and let's do number 9. Oh, you don't have to do that one for homework, right? Because it's just evens. So let's do 10. Find the measure of each interior angle of a regular dodecagon. So how many sides does a dodecagon have? 12. So how do we find the measure of each interior angle? 12 minus 2 times 180 divided by 12. What do we get? 150? So 150 degrees. Okay, and let's look at number 12. Find the value of y in the polygon JKLM. So we're looking at this polygon here. And y is in all of the exterior angles. So what do we know that all the exterior angles are going to add up to? 360. So how do you think we can find y here? We add them all together. So we have 4y plus 2y plus 6y plus 4y. So we have 360s equal to, now we need to combine like terms. So how many y's in total do we have? 16y. And how do we get y all by itself? Divide both sides by 16. 22.5. So y is equal to 22.5. So if we plugged in 22.5 into all of these exterior angles, they would all add up to 360.